Right. Okay. We'll start the class so that I can let them join. They can join. So I'm now I'm sharing the screen. I think everybody know. Everybody can see the screen of mine. So here, once you observe, I will explain how the cone has formed, how the cone will be formed, and in that cone, how can you find the surface area by using different values. This is the website where I can show you about this. So in this, I'm explaining about surface area and volume of cone. So once you see this, the surface area, once you observe this, what is a circle first? So I think everybody can see my screen. Everybody can see my screen. Yes, if you say yes, I may continue. If everybody can see the screen, yeah, just few messages so that you can type in the chart. If you can see the screen, say yes. Okay, then I'm continuing. So a circle is a two-dimensional figure formed by a set of points that are a constant at a fixed distance. That fixed distance is called radius and the fixed point is called center. This already we know previously. We have done previously this also. So once you observe this, this is the figure of the circle. Everybody know that. So in that, the total thing will be taken as diameter. The chord which joins opposite points and which passes through the center is called diameter. And the distance between the center and any point on the circle is called radius. And the part which the region which is bounded by two radii and an arc is called sector. These things we have done previously. Now we know all about what is a diameter and what is a circle and what is an arc. Now what is a cone? So see, observe the three elements of the cone are, for cone we have three elements. The three elements will be, one is radius and second one is height and third one is slant height. So once you observe here, one is radius and second one is height and third one is slant height. So these things we will mention here. What is the R radius in the cone? Radius in the cone is nothing but the distance between the center of the circular base to any point on its boundary. A circle has many radii as it is the distance from the center and touches the boundary of the circle at various points. That means if you go to that, the base of the cone V is circle. So if the base of the cone is circle, from the center to any point in this boundary is called radius. This is the radius. And the height is nothing but the perpendicular drawn from the vertex of the cone to the center of the circle is known as height. And this one is known as slant height. So these are the three components which you have to define for a cone. Slant height is nothing but distance between the apex of the cone to any point of the circumference of the cone. Apex means the vertex and any point on the surface. This is called slant height. Height, slant height, radius. These are the three things we have to find. Now we'll go with the area. See here, the area of the sector, you know how to find the area of the sector. Sector is nothing but radii and the arc. The region between the radii and the arc is called sector. We know that how to find the area of sector previously. That is nothing but area of length by circumference of the circle into area of circle. See, arc length is means this is arc. If you take that length as L, that will be 2 pi r. Circumference is 2 pi L. and into pi r square. This will be the formula for area of sector. Circumference, everybody knows that is 2 pi r units. Now we'll move on to that. This one we will move on to that. What we can say about cone. Now we're moving on to cone. I think this is okay for all of you. And I'm going to that. How we'll go with the cone. See that we are going to form a cone from a sector of a circle and to find the formula of its curved surface area. That means cone can be formed from, listen, can be formed from sector of a circle. That's why I have introduced what is sector before. So first to find that cone, first we have to create a circle with center O and radius R. I think we can have a circle here. After taking the circle, we will take the sector OAB sector here, and we will take that sector separate from main circle. With that sector, we can fold and we can form. See how we can form by using stimulation. You can understand now. You can see this animation. See that to form a cone from a sector, to find the formula of its surface area, first we have to check. Sector of a circle, we can aim form just now. Cone that can be taken from sector of the circle. Then how can we do? We can take the tool and we will take a circle. We will create a circle. After getting the circle, we will form a sector there, OAB, sector mark chesi, and then the sector OAB is cut out from the circle. We can cut out the sector part from the circle, outside of the circle, and that will be dragged out from the circle. After dragging out, because I have removed totally, that's why I have dragged out. With that sector, I will fold the ends. I will fold the ends of the circle with radii. If you fold like a paper, then it will becomes a sector like this, folding like this. We'll get a slant height and height. So these are the observations. Now the relations also we can study by using the simulations. Once you go through that, how can we do this? Yeah, now you can. Now you can see how it can be. See, first what I have done is, we are going to see how curved surface area of a cone can be formed by the sector of circle. We will create a circle and we cut out a sector from it, and we take that sector formed into a folding to form a cone. Then we'll compare the observations from the sector to the cone formation process to reach our result. Once you see the step by step, now I'll take a tool that is circle. I have taken the circle, and then after taking the circle, yeah, now I'll form a circle. See, after forming a circle, to mark a sector, I will mark a sector here. Yeah, see that I have marked a sector OAB, and then after marking a sector OAB, now click on the marked sector to cut it from the circle. Now see, this is the radius, the arc length is L. It will be cut out. See, I have taken out that sector by dragging from the circle. So whatever the sector I have taken, that is dragged out of radius R and length L. That sector will be colored differently and that can be taken out. So after dragging, see, folding those ends radii, and see, once again you can observe, I have taken the sector and the sector has been circle, which is the radius R and the length is, and then after dragging out, see, after dragging out length L and radius R, if you join If you join that length, see this radii OB and OA, if I join like a folding paper. So if I join that, I can form a cone. See how stimulation was worked there. So the radii was joined both sides. Then this will be the height, this will be the slant height. See the figure here, slant height, L and H and R. Relation between the radius of sector of circle and slant height of a cone. See what is the radius of circle? Radius of the sector of the circle R and slant height. Relation between arc length of the circle and circle the base. Say arc length, we will do that. And finally, we'll find the area of sector. See here, arc length of the sector is equals to circumference of the cone. That is nothing but 2 pi r. Once you apply this arc, whatever the arc I have taken, that arc becomes a circle here. Is it? ఏ ఆర్క్ అయితే తీసుకున్నామో ఆర్క్ మొత్తం ఏమైపోయింది ఇక్కడ సర్కిల్ అయిపోయింది. సో లెంగ్త్ ఆఫ్ ద ఆర్క్ ఈజ్ ఈక్వల్ టు సర్కంఫరెన్స్ విచ్ ఈస్ నథింగ్ బట్ 2 pi r. Now area of the sector is nothing but curved surface area of the cone. So we have to find the area of the sector so that we can go with area surface area of the cone. So calculation can be expressed as, see here, arc length by circumference of circle into area of circle. Arc length is that is equal to circumference of the circle 2 pi r. Circumference of the circle will be 2 pi r into pi r square. Then 2 pi r will be cancelled. We have finally, once you observe here, we have finally left with pi r r by 2 pi l into pi l square cancelled. We have left over with pi r and see r was left over here and l over left over here. So we got pi r. Radius of the base of the cone is pi rl. That's why you mentioned that curved surface area of cone equals to curved surface area of the cone is equals to is off of the diameter to keep here pi d and l. So CSF cone in terms of diameter. Yeah. Find the curved surface area of a cone whose base radius is 7 centimeters, slant height is 16 centimeters, and pi equals to 22 by 7. Now you apply the formula and complete the answer. Quickly say who will say the answer. The first question. Curved surface area of the cone whose base radius is 7 and the slant height is 16. Then can you see the screen? I think now you can. Yeah. Now say the answer, the first question answer. I didn't get from any. Find the curved surface area of the cone. The question is C. Find the curved surface area of the cone whose base radius is 7 centimeters and slant height is 16 centimeters. Yeah, do it. Ravi is saying the answer is trying. Yeah, radius r is equals to 7, L equals to 16, pi you have to say 22 by 7. So yeah, Ravi, answer is given 204 centimeter square. So Ravi, answer is 204 centimeter square. Is it right? Can anybody say? Yeah, it's absolutely right. So how can you say that once you observe? That is very simple and very clear. The first one is given very clearly. That is nothing but your answer is pi RL. So pi RL is nothing but 22 by 7 times radius is the given 7 and slant height is 16. So 7 get cancelled. 22 into 16. Yeah, 22 into 16 to 32, 3. 16 to 32, 3, 352 centimeters square. That's the correct answer is, yes, that the correct answer is Satya's. Satya is given the right answer, 352 centimeters square. That's wonderful. That's the correct answer. Right? We're moving now the second question. Now you try this. Find the curved surface area of the cone whose base radius is 6 centimeters and slant height is 14 centimeters. Now you have to say this one perfectly. Try here. Radius r equals to 6 and slant height is equals to 14. Okay, come on, quick. Whoever says this. Yes, Satya is right. And I'm asking the second question. Find the curved surface area of a cone whose base radius is 6 centimeters and slant height is 14 centimeters. Now make it quick. In the place of R, you have to write 6. And in the place of L, you have to write 14. 264 given by Satya again. Check, we will check it again. So pi RL is nothing but 22 by 7 times radius is 6 and slant head is 14, which is nothing but 2 times 6 twos are 12, 12 twos 24 to 12 twos 24 to 264 centimeter square. Yes, again the Satya and Varma both are right. So 264 centimeter square. Now we'll have only 10 questions over here. After completion of 10 questions, we'll conclude the class. See, now the third question is different. Find the slant height of the cone if CSA of a cone is 88 centimeter square and radius is 1 centimeter. So the formula is same, but they have given pi r is equals to 88 and r is equals to 1 centimeters. Then find the value of L. So I'm waiting to see the answer. Will you try it? Try it the question. Yeah, you can note and try it the question. Find the slant height of the cone if CSF a cone is 88 and radius is 1 centimeter. Yeah, I'm waiting. We'll make it quick. One of you can respond the answers. Are you right? Are you doing? Yeah, yes, you can. So CSF a cone is 88 centimeters and radius is 1 centimeter. Then what about the value of L? You can say the answer okay, then I will continue. Otherwise, I will explain the things. So one of you respond. Are you doing still? Yeah, okay. Someone is saying that answer. So can I explain? Are you doing anybody? Satya, Ravi, Venkatesh, Murali, one of you can respond. Okay then. See here. Pi means 22 by 7. I think everybody can see here. 22 by 7 into radius is 1 and slant height is L is equals to 88. Now how to find the slant height? L is nothing but 88 into this 22 by 7 goes right hand side and it becomes 7 by 22. So 22 in 88, 4 times it will get cancelled. Then L is equals to 28 centimeters. The slant height will be 28 centimeters. If CSA of a cone, CSA of a cone pi RL is given 88 and the radius is given 1 centimeter, then we have taken pi is 22 by 7, radius is 1 into L is equals to 88. Then L is equals to 88 into 22 by 7 becomes 7 by 22. This cancelled in 4 times. 4 sevens are 28. Actually, the right answer is 28 centimeters. But they didn't given here. Just we'll go through the 14. And the same problem, the fourth one is given. Yeah. Find the diameter of the base of a cone if slant height of a cone is 7 centimeters and CSA is 88. The same question given. CSA is given 88 now. And slant height L is equals to 7. Then what is the radius? Will you try it? First you find the radius. It is very easy. You can do it now in the same method. Yeah, are you doing? Are you trying? Type S. Please repeat. Okay. So the Verma has given the answer 4. So we'll check whether it is right or wrong. So in pi RL, I can write that 22 by 7 into R into L is nothing but 7 given is equals to 88. 7 get cancelled. R is equals to 88 by 22, which is nothing but 4. So R is equals to 4 centimeters. That's absolutely right. That's absolutely right. That's good. Super. So we'll get the 4 centimeters is the right answer. Venkatesh also, that's nice. And if the see the fifth one, if we double the radius and slant height of a cone, then CSA of increases by. So for this, once you have to see the initial CSA, first CSA, let us take this one as C1 is equals to pi RL. This is pi RL. Now, what happened? The radius is doubled and the slant height is also doubled. Therefore, C2 becomes C pi into 2R into 2L. So, nothing but, if you observe, this is nothing but pi into 2 into 2, 4RL, which is nothing but 4 into pi RL. So, first one is pi RL, so 4C1. So now the second surface area becomes 4 times the first surface area. So if you double the radius and double the slant height, then we will get the CSA will be increases by 4 times. The meaning of this is, if the radius is 2 centimeters and the slant height is 7 centimeters, your arm is 44. If the radius is 4 centimeters, slant height is 14 centimeters, your answer will be 4 times. 4 into 44, you will get that double that, 4 times that total area. That is the meaning of this way. And we'll move on to the sixth question once you go through that. A right circular cone has a radius of 6 centimeters, slant height is 10 centimeters. What is its curved surface area? I think everybody can do that. No need to substitute the value of pi. You please give me the answer. Sixth question answer you can definitely say. Question number 6. Direct answer. I think everybody can say simple answer. The sixth one is simple answer. You can do it. Radius given 6, slant height given 10, curved surface area. No need to substitute the value of pi. Pi value substitute cheyakarledu, simple. So one of you can respond. Amma, Venkatesh, Murali, Satya, Hemant. Yeah, please. Are you there? Just you can say the simple answer. $120. How can you say that 120? So CSA of a cone is pi RL. So pi is pi. No need to substitute. What is the radius here? Radius is 6. And what is the slant height here? Slant height is 10. So what you will get then? 6 into 10? 60. So your answer is 65. So not 120, it will be 65. So well tried. Okay, we'll do the next. If the slant height of the cone is equal to its radius, what is the curved surface area of the cone? Slant height and the cone both are same. Slant height and cone both are equal. Then what is the curved surface area of the cone? So CSF cone, we know that the formula is pi RL. So pi RL means pi into R into slant height and cone both are same. Then what will get? Pi R square. Either pi R square or if both are equal to 1, it becomes pi. So and then eighth one. Eighth one you can do this. That is, the radius of the cone is given, R is equals to 5 centimeters, and CSA is given as 25 pi. Then what is the slant height? If you see that CSA is nothing but 25 pi is given, that is CSA. That means pi or L is equal to 25 pi. Both pi get cancelled. The radius is 5 centimeters and slant height, I don't know, L is equal to 25. Now what is L? L is equals to 25 by 5, which equals to 5 centimeters. So the slant height will be 5 centimeters. The same will have the 9 and 10. So you write down that problems 9 and 10. You can give me the answers in your book tomorrow. The curved surface area of the cone is 154. Radius is 7. What is its slant height? So very easy. That is already CSA pi RL equals to given 154. The radius is given, pi is 22 by 7 and radius is given 7 into L is equals to 154. Both 7 get cancelled. We'll get L is equals to 154 by 22, which is equals to 7. Then the length of the slant height is also will be equal to 7. Radius is 7 and slant height they're asking. 154 divided by 22, which is equals to 7 centimeters. And then the curved surface area of the cone is given, slant height is given. Then what is its radius? The same can apply this 144 pi. Pi RL is equals to 144 pi. Both pi get cancelled. The radius is given. They didn't give the radius and slant height is given 12. 144. So R is equals to 12 in 144, 12 times. The radius is 12 centimeters. So they have given some different answers, but we can go with that, everything. So whatever the things that can be given, they have given the wrong answers there over there. You don't worry about them. So this is your curved surface area of the cone. So this curved surface area of the cone can be taken like pi RL. Using pi RL, except pi RL, we can find curved surface area of the cone by using this formula. By using this formula, you can go with radius or slant height also. So tomorrow I will come with the example problem, exercise problems, whatever there in the textbook, whatever we completed here, and we can continue that in the next class. Tomorrow we will do it, and thank you. Thank you. Bye.